Okay, let's get started. So, hey everyone, I hope you're having a good conference. Uh, I personally could not make it to Toronto, but Prefect did send some people, and we do have a sponsor booth. So, if you're interested to learn more about Prefect, you can find them. But today I'm going to be talking about lessons learned from DAG-based workflow orchestration. This talk will not be like an intro to how to use Prefect. This talk is primarily about Prefect 2.0, which is a new version of Prefect, and Prefect 2.0 specifically eliminated the DAG requirement. Uh, if you're not familiar with what a DAG is yet, we'll talk about that in a bit. But basically, this is a talk about the motivations of how the DAG introduced friction into workflow orchestration and how and why we decided to remove it. So my name is Kevin Cope. I am an open source community engineer at Prefect. If you're not familiar with Prefect, Prefect is a workflow orchestration framework. Prior to Prefect, I was a data scientist for 4 years, and I just found myself doing more deployments and doing more of the like ML ops portion of things, and then that's how I ended up with Prefect. I outside of work, I also contribute to open source, primarily with a project called Fugue. Fugue is an abstraction layer for distributed computing. So we take Python, Pandas, and SQL code, and we bring it to Spark and Dask. And outside of the open source work, I am also an organizer of the Orlando Machine Learning Meetup. So I'm based in Orlando. So today we're going to be talking about what workflow orchestration is. I know some people may not be familiar with it, so we'll go over like a simple example to build that intuition. And then we'll talk about what the problems were with previous workflow orchestration frameworks. And then after that, we're going to show how people already have uh, a grammar to create workflow orchestration pipelines using vanilla Python. And we'll talk about how removing the DAG enabled people to just use pure native Python to express their orchestration logic. So first, let's talk about workflow orchestration. It's a very self-explanatory term. A lot of people, you kind of see it and then you already have a feel for what it means. Basically, you have some kind of steps that have to run in some certain sequence. They're dependent on each other. Workflow orchestration is the one that manages that. But a lot of people have more like slightly different definitions of what exactly goes into a workflow orchestration framework, right? So I think the best way to think about it is that there are a family of tools such as retries, checkpointing, restarting from failure, logging, monitoring, and these features collectively uh, are bundled up as workflow orchestration. So let's talk about a simple pipeline and why you would use workflow orchestration. So here we have a Postgres table, a Postgres job that outputs a Parquet file or any CSV file. And then this file is combined with API data and loaded into a Pandas data frame. Then the Pandas data frame is we run it through a machine learning model, and during that training, maybe we're outputting some artifacts to MLflow, and maybe based on some metrics that we track, we want to output it to Flask. So if we look at this pipeline, there are a lot of interconnected components, right? Basically, everything really here is interconnected. But like, for example, if this Postgres database is not available, what happens to this Parquet file? We don't get it, right? What happens if an API call goes down? We don't get that data in our pandas column. Do we still want to train downstream models if in the event that that happens? So what we're going sorry. So do we want to train downstream models in the event that that happens? Or for example, if the sklearn model fails, do we want to still train this? Do we want to still register artifacts to MLflow, right? And if you look at the ways that this can fail, it can really fail in an infinite number of ways. The database may be under maintenance, the API may be unhealthy for a given moment in time, and data may come in malformed, right? MLflow, we may not be able to register artifacts. Um, Sorry, I see a question. Is there a Git repo? So I will just type out what the Git repo is in the chat. So here, and then here we have, so if you have all these potential points of failure, and you might be thinking, well, what happens if the API calls? I can, code my own retries, and just like retry it the next minute, for example. Hey, if the database fails, maybe I can just use a previous file. If MLflow is failing, maybe I don't care. It's okay. MLflow is not critical to the deployment anyway, right? Like maybe uh, I lose some plots, but that's fine with me. So you can control a lot of these failure modes yourself, and you can build failure paths and code those in. But the more you do that, the more time you actually spend on these failure paths than actually building what you set out to begin with. If you're a data scientist, your goal is to make a recommendation model, or your goal is to predict which customers are leaving your platform. These are business outcomes that you want to achieve. But what we find is that data scientists often find themselves more occupied with the other side of things, the negative, what we call the negative engineering. So negative engineering is when you have to code these failure paths, these send yourself notifications when the pipeline is down, give yourselves more observability, monitoring. Maybe if your code fails, you want to do some other failure, introduce some other failure logic, like you want to, for example, use a previous model or something like that, right? So these things are things you can definitely code yourself, but it's not worth your time. And that's why when you should start to look for frameworks, workflow orchestration frameworks specifically, that have these features built in already, so that you can accelerate the development of your data pipelines or machine learning models. So what we found when Prefect started was that 90% time of data science time or data engineering time was spent on this negative engineering. So for Prefect, our mission is to eliminate negative engineering. And if we can eliminate negative engineering, or if we can reduce negative engineering from 90% of the time to 80% or 70%, then we can double or triple developer time for the business outcomes that you want to achieve. So Prefect is an open source workflow orchestration, Python based. We have a GitHub repo. I posted it in the chat. We have 9,000 stars right now, and my job my title is open source community engineer. Most of my work is maintaining the Stack community, helping people adopt Prefect. I've seen all the ways that people can fail with Prefect, and I'll talk about that today. What those common what those common uh, misuses were, and and how the DAG is tied to that. But in Prefect is also has its roots in the modern data stack and has a native Dask integration. Before Prefect was, if you are familiar with Airflow, and Prefect's inception was about how do we get Airflow-like semantics running on top of Dask, and utilizing Dask's millisecond latency scheduler as opposed to the monolithic Airflow scheduler, right? So right now there was Prefect 1. There's Prefect 1.0 and Prefect 2.0. Prefect 2.0 is also called Prefect Orion. So if I say Orion, that's Prefect 2.0. And if we want to, and the reason we entirely built 2.0 is because historically workflow orchestration frameworks are pinned to this concept called the DAG, right? And if you're not familiar with what a DAG is, a DAG means Directed Acyclic Graph, and it's a concept rooted in math, but it's a convoluted concept for what we actually intend to do, right? So if you're not familiar with a DAG, this is basically already a DAG. You just have a couple of steps or nodes in your pipeline, and you draw arrows between them. So the directed means that this is the order of operations. Acyclic means we cannot have cycles because you run into infinite loops. And then the graph is just a representation of this, right? So this is already a DAG, basically. And in 1.0, this DAG was a requirement. You need to have all your steps predefined already. Whereas in 2.0, we eliminated that requirement. And we'll be talking about the lessons learned that led us to eliminate that requirement. So here's some basic Prefect 1.0 code. Here we have a function. So the only Prefect code here is this task and the flow. The rest is just normal Python. So we have a Python function to get GitHub stars and another one to print it. All you have to do in Prefect 1.0 is say with flow as flow, and then call your task inside. And then you can call flow.run for local prototyping. And then you can call flow.register when you're ready to actually deploy it. And then you would comment out flow.run. And then now you would register this graph is generated in this flow block, and then you would register that on Prefect Cloud. And then when you run it, it's going to execute this, right? So Prefect already succeeded in a lot of things. Number one, a very Pythonic experience. This is just native Python, except for the decorator. You can pass data between tasks. Other frameworks don't necessarily let you do that, and this feels very Pythonic. It just feels like I'm calling functions. But what we're going to be talking about specifically today is this build time versus runtime, because this thing is actually executing already. Like if you call flow.run, it executes all the code. But if you don't call flow.run, what this piece of code does here with flow as flow, it actually builds that graph for you, right? Under the hood, it's actually building a static graph. And a lot of people find confusion with that, and we'll see why later. To give you a taste of 2.0 code, we took out that flow with flow as flow, and now we have a flow decorator instead. So this is the same, but the more important thing is we have a flow decorator instead, and inside the flow you call tasks. And now you can just call this function as if it were normal Python. And by decorating it as a flow, we add observability and monitoring and scheduling to it, right? So it's even more Pythonic. It feels very native. And then the more important thing is there's no static registration. So we have dynamic DAG-free workflows. And the DAG inherently has some certain scenarios that can't be modeled. For example, if a task comes in and you said, oh, like for example, GitHub stars, you said, oh, the GitHub stars is below 5,000. I want to run this other thing. And then if the GitHub stars is above 1,000, you have to run this other thing. Like you cannot dynamically add tasks. And I'll show what the workaround in Prefect 1.0 is. And then you cannot repeat tasks. So for example, I said, hey, I noticed the last 7 days of data is not processed. I want to run 1 week ago ETL, and then the next day ETL, and then the next day ETL in a sequential order. You can't do this. It's very hard to code in the DAG because it violates the acyclic constraint, right? And then if you wanted to run some sequence of also, so this is the sequence. So, and then the other one is long running flow. So what a lot of people want is like they have a long running flow and it keeps checking for a certain condition. And if the condition is met, then it does an action. So for example, you keep watching S3. Hey, if there's a new file loaded, then I process that file as a task and move on, right? So long running flows was also not allowed because you needed a predefined DAG in place. So this is a comment that was on Hacker News, and somebody said Prefect 2.0 is a first principles rewrite that removes most of the friction from interacting with an orchestrator in the first place. Finally, your code can breathe. And we'll show why this person said this, and this is the inspiration for this talk. So number one is that DAGs make data access hard. So we said here that there is a DAG that's actually being formed. And if you do, for example, we run this extract task and it returns a list of 1, 2, 3. And then we want to pull the second element over here and then pass it on. This is actually valid, but there's magic there that makes it valid. Let's look at what an invalid code looks like. So here we have extract, which is the same thing, but here we do e.pop. And pop is a list operation, right, where we take that first element, and then we pass on the E1 again downstream. This will fail with this specific error message. And it says, hey, this function task has no attribute pop. Why is that? This is because pop works on lists, and E is not a list. Even though it will return a list eventually, it's not a list when this flow is during build time. It's still a task. And that's why you get this function task has no attribute pop. So why does this work up here then? Why can we access it as if it were a list? This is because Prefect had added a convenience method in 1.0 so that this bracket here is actually a task. People just don't know it, but it's a task. And because of this magic that is added, there are times when it feels like you're just working with Python until you run into this, where you can't mix native Python, non-task code with task code, right? Everything in the task, everything in the flow block needs to be a task because tasks are the mechanism to defer execution to runtime, right? So I build a graph with all of my tasks, but nothing runs. And then when I register and I run it, it eventually runs. But while I build it, it's still a task, right? Let's look at another example. Let's look at how we would correct that example first in 1.0, we would need to make another task called pop that just does the pop operation and returns it. And then we have to do it like this. Like there's no other, like everything in here needs to be a task so that all of them go through build time and then also through runtime, right? So here we added a lot of boilerplate code for our user because of this DAG requirement. This gets even more complicated when we talk about like parameters. So for example, look at this code above. Note that this is incorrect usage. I want to get, every time this flow runs, I want to get the current date, and then I want to run that date through extract, transform, and load, right? This is wrong. Why? When you register this is not native Python code. So the value of today will get fixed. So if today is June 8th, and then this flow runs on June 9 or June 10, today is already fixed to June 8th. How do we fix it? Again, we have to make a task. And the task will defer the execution of this datetime.date should be today. And then we can call our task and pass it downstream. So dynamicism inside the flow block cannot happen because everything needs to be fixed ahead of time. Some people, they try to create a parameter, right? And they try to make this callable datetime.datetime today. It's the same thing. This will run during build time. Specifically because the way the flows operate is through API calls, and APIs need to be JSON serializable. I mean, not that it really matters. The point here is that this is evaluated during build time. And the point is that users find this awkward experience of build time versus runtime. So how if a user comes in our Slack channel and says, this code is fixing the date to the build time, how do we fix this? What we have to do is, again, we have to make another task to fix it. And what we tell them to do is we create a parameter, and the default is a string called today. And then if the default came in, we return today. Otherwise, we assume some string came in and we return that instead. And then now we have a parameter. There's a default value. We have to call this getDate task just to get the new, parameter that's formed. So we add so much boilerplate code, and because of this static DAG requirement and having no dynamicism in the flow. And I'll show how 2.0 fixes this. But because of everything needs to be fixed during registration time, you end up increasing the amount of boilerplate that your user has to write. The next thing is conditionals inside the DAG. So here I have a flow block, and I'm going to check the condition. And if the condition is met, I use transform 1. Otherwise, I use transform 2. So these are two different tasks, right? And the output of either of this, I'm going to pass in my load task. Now, if I register this and I look at the schematic, I get this. Transform 1 is missing. Why? Because we use an if statement here, and this if statement was evaluated during build time. If and else here are evaluated during build time. So condition is of type task. But because Python allows this comparison, even though it doesn't make sense, what we get is that this condition will never be true because this is of type task. It's not a Boolean, right? It's a task that hasn't materialized as a Python value yet. So now this evaluates to false, and we get transform 2 instead. And this is never included inside the DAG. So how do we go around this? We introduced this task called case. And case is like the Python if, except the only thing is that it's strict equality. But basically, we created another task that mimics the if behavior, but instead of running the if now, it runs it in the future. So we made our own task, right? Because everything needs to be a task. And then we said with case, and then we can run this other transform. But this has issues as well, because it can cause unintended skipping of work. So what happens here is that the DAG creates all the potential branches already. And during runtime, it follows one branch. And for the rest of the branches, in conditionals, it will just raise a skip signal, and the skip will propagate. And this is an example of that. So we have all this fork already coded in. But what happens is that this evaluates to false. So the case will skip everything underneath it. This is coded in, it just gets skipped. But then because this gets skipped and skip propagates to downstream, the load is also skipped. If you didn't follow this, that's okay. I'll move on, but just note that there are times when because of the way you really need to understand what the DAG is doing and the path that it's taking code-wise. So how do we fix this? There's another task now that we have to introduce called merge, right? So we have case, and then T1, T2, we have to merge them. Merge is like it gets the first non-null value or the non-skip value, and then we can pass this. So now we have to force users to use this merge case instead. The next thing, if you use native Python for exception handling, you're already familiar with try except. But again, these will run during build time. So what you have to do is you have to learn this abstraction that Prefect has called a trigger. And this trigger is called any failed. So if any of the upstream tasks failed, I'm gonna just skip the next task. So here we say, hey, if any of them fail, I'm gonna run the next task. So here we have fail message because the trigger's any failed. If any of the upstream guys fail, this fail message will, let's say it sends a Slack message, will send a Slack message to us, right? But there's also like a slight edge case here. And the edge case is that trigger is based on state. Did the upstream task succeed or did it fail? We introduced case earlier. Case is built on top of the result. Is this value true or is this value false? And when you have to combine like a combination of state and result to decide to fire off a next task, like for example, a downstream task has one task, like run this if A is succeeded and B is greater than 5, like something like that, that becomes very hard to express in Prefect now. Not a very common use case, but it shows that there is, by constraining the system, we prevented the flexibility that native Python offers. And of course, this is what I mentioned earlier. The number one thing with DAGs are acyclic. You cannot get, if I have a date range that comes in, I can't use a while loop and say ETL for each of the date. You cannot do this because the number of tasks needs to be set during registration time. You need to know all the tasks that are running and the order of them. So something like this cannot be done in Prefect 1.0 because of the DAG requirement. Everything needs to be fixed. The graph needs to be constructed, and you need to register the graph. This is dynamic and has an indefinite amount of tasks. So how would you do this in Prefect 1.0? No need to pay attention to the code. It's very painful. Good thing we moved away from it. But you have to create this task called run loop. And there's this loop signal, which is kind of a hack. So instead of looping over ABC, you compress ABC into one task, and you loop that task until it's done. So you lose a bit of observability. You have to compress everything. We have to compress, extract, transform, and load, right? And this is a very ugly user experience. But that's not because Prefect messed up. I think it's because of the DAG requirement specifically that this operation becomes hard. And we solved a way to do it, but it's never going to be graceful to the user. Now I'm going to show how moving from Prefect 1 to 2.0 and allowed people to actually use native Python instead as the grammar for workflow orchestration. So instead of Pythonic, we now really just use Python. So number one is we showed this Python data access, and we showed that you could not do operations like pop. So this is a task. This is not a task. And you could not do operations like this. But in Prefect 2.0, this is a future now. We don't have a DAG, so this is just a runtime DAG now. And if you submit a task like extract, and you need to use the Python object under the hood, you can just call .result. And .result will return the list, and then now you can pop the list and pass it. So DAGs make data access hard, and by removing the DAG and just using futures instead, we can just now call .result on anything and get that object. And then we can mix that with native Python code, right? Here, the dynamicism where we do datetime today, this just works now. It just works. This does not need to be a task, but then it's not run there's no registration concept anymore. So now this is only run every runtime. And now this, because this whole flow block is deferred, this just works. Native Python, that's fine. The same thing with parameters. Let's look at the parameter. Before I showed you this really long code block, hey, the default parameter is today. And then based on the value of today, I'm going to parse it. I'm going to return something else. Now we can just use today and set it to none. And if you're not familiar with the OR, it just returns the first non-null value. I will send my slides out. I'll give a link to the slides for sure. I'll upload them. So with this here, so today we set it to none, and now you can say, hey, if there was a value provided, I'm gonna return it. Otherwise, I'm gonna run datetime.datetime today. So that 10 lines of code earlier gets expressed in one line of Python now, and this is just pure native Python. You'll notice I also have datetime.date here. There's just a like Prefect uses Pydantic now, so if you pass in anything, it will convert it to this type before it gets passed into the flow. So there's type validation here on the flow level as well. That's a new feature, and that also is why this is so this expression is so simple and so Pythonic, because if you pass in a string here, it gets converted as a date over here already. Conditionals, again, we just have to call .result, and then that is true or false, and then now we can use if else inside our flows. So instead of using that case task, now we can just manifest that Python object, wait for the future to resolve, get this list or true or false, and then pass it downstream, right? So again, you can mix task code with non-task code as well. And now you can just orchestrate yourself the conditionals using if and else. Exceptions. You can use try and except now inside the flow. They're not evaluated during build time because there's no build time. Instead, there's only one runtime. And with try except, here I just say try these tasks, and then I just have to call .result. This is not the best way to do it. I'm just showing that you can use try except. And if there's a failure, I just raise the error, and then it will go here to the except block. Now, there's a nicer way to do it, and you can just use an if as well. And we can say, if any of these fail, ETL. So we call .wait .is failed, and if any of them fail, we run the fail message, right? So the if is a more flexible expression for dictating whether or not downstream tasks should run. Very Pythonic. Users already know it, so we should just let them use it rather than learning triggers, right? So you can use try except or if, whatever you want to do. Try except gives flexibility with handling different kinds of exceptions as well, so that's also an option. The last thing, loops. This thing, I showed 1.0 code and I said this doesn't work. Here it just works. It will work because we don't have a DAG, so this can loop however many times you want. You can have infinite flows for all we care that just keep checking and submitting tasks. This will now work, and you can chain together this sequential ETL of every day. So the future of Prefect, I'll get to the questions. I just want to say that we purposely are trying to redefine workflow orchestration by eliminating the DAG to support the flexibility of use cases of today's today's data ecosystem needs. And what I find is that instead of writing Prefect and learning Prefect, you just need to know, if you know Python, you can orchestrate your data pipelines. And with that, thank you. I will upload my slides as is being asked in the chat, and I will get to the questions now. So a question from Benjamin. This is the first time hearing Prefect, and it sounds cool. Is it used for orchestrating machine learning tasks or focused on ETL? It can be both. Again, it's just Python. But what we do see is that a lot of people combine Prefect with specific machine learning orchestrators as well. So for example, if you know Metaflow, MLflow, you can have them as a portion of your Prefect DAG because Prefect is more general purpose, whereas those are more machine learning focused. So they have added features like registering artifacts, keeping experiment tracking. They're very good at that. We can just use them inside Prefect, right? So Prefect can handle the upstream transformations before you go there also, and you can connect everything, right? So if you need heavy duty machine learning with experiment tracking, I would say that use your ML flow, use your meta flow. Just you can use that as a sub operation inside Prefect. Shrusti is asking, would it be possible to download my slides? You know, I'm gonna I'm gonna like put it in the chat right now while we speak. Mudge, I'm sorry if I butcher your name, is asking, now that 2.0 is no longer static, I am going to anyone with the link, and I'm gonna copy the link and give it to the chat so you already have it. And then I'm gonna, okay. Now Majid is asking, now that 2.0 is no longer a static DAG, are you able to resume a workflow from having a failed step without having to re-execute previous steps? Do you checkpoint the result of each statement? This is a very good question, because when you have the DAG in Prefect 1.0, if you have A, B, and C, and A succeeds and B succeeds, but C fails, you could restart from A and B and then get C, right? Just start from C and proceed, because we already cached the result of B. Now in 2.0, because there's no DAG, yes, this is a lot harder to do, but it's not like we're going to not do it. The issue is that because you have native Python code that is not tracked, that can change the flow run and in a way that's not cached. There may be ways around it, like for example, caching the inputs into a task before it fails or something like that. But it's definitely something we have to explore more, definitely. But in some way, like you can keep everything inside the workflow as a task, and maybe if you do so, you can get retries, right? So there's stuff like that. You just lose the flexibility of using Python. So it's a give or take, but it's entirely in the user's hands. I will say that with regards to restart, it's not. We're still in beta right now, just to be clear, and general availability will be out in 2 months for 2.0. I would say that restart is not part of the general availability roadmap. It's an item that will take a lot more exploring. Tony asks, what are major competitors? Are there AWS SageMaker, GCP Vertex, or offerings trying to do similar things? So the answer here is that our competitors are like Airflow, for example. That's a competitor. If you are primarily using AWS, there's this thing called AWS Step Functions. If you're in Azure, there's Azure Data Factory. And Google has like Orchestrator or something like that. I forget the name of Google's. But what you want though is that if you have a general purpose orchestrator like Prefect, we can orchestrate across cloud stuff as well. So if you have AWS operations and you're working on like Snowflake, dbt, like these other data tools, Prefect is a glue for all of these. If you're within, like, for example, you're in Databricks only and everything's in Databricks, you can use the Databricks orchestrator, like no problem. You can use their workflows. But inevitably, your data will connect to things outside one tool. And that's when you would use a tool like Prefect. Adil is asking, is there a trial? You can sign up for Prefect today. 1.0 is free to use. You get 20,000 free task runs every month. No questions asked. Way more than enough to get started. 2.0 has no pricing yet. The beta's open. You can just go and use it. No problem. The free tiers of Prefect are very, very generous. And it's very fun that way. Like even for like a hobbyist, you can spin up a Prefect project. Like Prefect, you can use Prefect as the orchestrator for free. Arthur is asking, to Tony's question, could you compare why one might use Airflow versus Prefect? Yes, I can. So our roots come from Airflow. The Prefect founder was at one point that had the third highest commits in Airflow, and Prefect came from a list of changes that he had to bring Airflow to 2.0. The list got rejected, and that's when he made his own orchestration framework. Now, Prefect, why would you use Prefect over Airflow? I showed you the passing of data, for example. It's very Pythonic. I think we provide a way better developer experience. If you do like a checklist style thing and you say, what are the features of Airflow? And what are the features of Prefect? I think a lot of the times you'll find it's one-to-one. But what we find is that a lot of people migrate because of the developer experience. Number one is that Airflow primarily encourages a monolithic repo, monolithic server. Everything is run on the server. Prefect is very decoupled infrastructure-wise. Our scheduler is just a scheduler, but your flow does not run there. Your flow runs in many different places, and you control where it runs on your own infrastructure. So a lot of people find that it's very easy for them to decouple projects and decouple dependencies, and just very easy to deploy stuff. So I would say it's the developer experience, and it's probably will make more sense like if you like do like a flow like prototype with flow.run and register and see what the user experience is. Radu is asking, what is the complexity of hosting Prefect on AWS? For 2.0, there is barely any complexity. 2.0 comes in as one Python package, and that Python package includes the UI, API, and the interface. And so you can just do pip install prefect 2. Make sure you do 2. If you just do pip install prefect, you'll get 1.0. If you do pip install prefect 2 and above, what you're going to find is you can just do prefect Orion start and you spin up the server. It just works on your local. As long as you're not Windows. Windows has some, yes, we have Windows support, but I've run into issues with like Windows firewall blocking the port from being occupied, stuff like that. So I would say that I know this, I didn't get into Prefect here so much as using it. I just wanted to talk about the DAG in general. But what I encourage you to do is like, you can try to spin up Prefect. And it will work on AWS. I've tried this myself. I will leave my email here, and if anyone wants to email me, please do. So like for you, Radu, I encourage you to email me, and I will get you a video of how to deploy Prefect on AWS. I already recorded one. I just don't have it readily here. Last question, Matthias is asking, Prefect 2.0 looks really awesome. I've never used 1.0, but I use quite a lot. I recognize all my problems mentioned. My question is, what is actually happening under the hood when you use that result? Is a task responsible for applying the subsequent methods called. When you call dot result, it's like Dask, if you ever use Dask, or async, for example, and it's like awaiting async. You have the future is just a promise, and when you call dot result, you wait for the completion of it, and then you do something, right? The thing with Flight is that, I mean, I know them, I understand what they try to solve, but like they are Kubernetes focused as the abstraction. And by being Kubernetes focused, it's not necessarily for the data scientist persona, right? It's for the DevOps persona. And I think that what we find in Prefect is that because of the simplicity, like we allow you to deploy simple workflows, but you can go complicated as well. What we find in Prefect is that data scientists can be responsible for the workflow orchestration of their own machine learning pipelines. To answer you though, the basic answer, the dot result waits for the completion of a task. That's really it. It's a future, so it materializes the future. Radu said, thank you. Sarah talked about how to version pipelines with Prefect. This is a very good question. In 1.0, the version just kept going up every time you register. In 2.0, what we can do is we can have, like, for example, a dev version and a prod version, and you can have those simultaneously. And the dev version gets like another branch of GitHub, for example, and the prod version gets another branch of GitHub. You can do that because of the abstractions in 2.0. 1.0 could not support this, but we intentionally decoupled deployment versus the flow logic. And by doing so, we allow more flexibility in that. If you want more detail, feel free to message me as well. Adil said, we'll get in touch with you over email. For any of you, you can get in touch with me with email. I handed over my email in the chat. For those of you who are watching, it's kevin@prefect.io. And I also want to mention we have a Slack channel as well, prefect.io/Slack. And also, you can find it through prefect.community. I encourage you to join our Slack channel to ask any question, any follow-up. I'm there, it's my job. I'm there every day. If you want to talk about workflow orchestration in general, have more questions about Prefect versus X or Y, happy to answer all of them. And yeah, thank you so much for coming and hope to be in touch with you. Thank you.